The sight of an opal for the first time left me in complete awe. I vividly recall standing in the geological pavilion of a museum, completely captivated by the iridescent beauty of a Brazilian opal. Its dazzling display of colors seemed to sparkle right before my eyes. I was amazed. Later that day, I discovered that these mesmerizing gemstones are extremely rare and can only be found in a handful of locations around the world. One such place is Coober Pedy, a town in South Australia, which is renowned as the opal capital of the world. Interestingly, Coober Pedy's connection to opals is not widely known. What sets this small town apart is that its residents live underground. They've carved houses out of the stone where they eat, sleep, and breathe. This unique way of life got me thinking, could opals potentially hold the key to our survival on other planets, such as Mars? The issue of living on Mars. Mars is an inhospitable place and should not be traversed for extended periods of time. The harsh conditions on its surface, as evident from rover images, are both scorching and frozen. Even the most advanced spacesuits would eventually wear out, and the best habitats may not effectively shield from micrometeorites. Essentially, the unforgiving Martian environment poses a significant threat to one's life. Exploring the outdoors on the Red Planet would require specialized individuals. Taking inspiration from a Mars rover bike concept, highly advanced rover bikes could be used to navigate the terrain. These bikes are designed to take advantage of the frequent storms on the surface of Mars, but we strongly discourage long excursions. It is essential for colonizers to have clear understanding of their mission and only venture outside their shelters to fulfill specific tasks. Any time spent on the surface could prove fatal. But the real killing factor here would be radiation. Despite Mars being much further from the Sun than Earth is, it has lost its inner dynamo. This refers to the generation of a magnetic field within its core due to the motion of molten metal. It is a crucial process for protecting a planet from solar wind and radiation. On Earth, the dynamo effect is active because our planet has a liquid iron-nickel outer core in constant motion. This creates a strong magnetic field that shields us from harmful solar radiation. In contrast, Mars used to have a dynamo effect, but it weakened as its core cooled over time. Now Mars has a much weaker magnetic field, leaving its atmosphere more vulnerable to solar winds and contributing to the loss of its once thicker atmosphere. In such circumstances, the Sun, which is the very source of life in our solar system, has the potential to harm us due to the combination of a very thin atmosphere and a significant amount of ionizing radiation reaching the surface. Despite potential ways to lessen solar radiation, heavy shielding is the most effective solution, with studies confirming that approximately 15 centimeters of steel, 1 meter of rock, or 3 meters of water would be necessary. Living underground for most of the time would be the simplest solution for humans. Therefore, the experience gained from carving stones to create comfortable habitats, similar to what the citizens of Coober Pedy have done, becomes valuable. Coober Pedy. In 1800, a time of great explorations, John McDougall Stewart passed near the site of Coober Pedy. Some years later, in 1915, Willie Hutchinson discovered the first opal in the area. Needless to say, the promise of finding more and more opals sounded very appealing to European explorers. And this is exactly how and why the town was established. Soon after that, a lot of opal miners started moving in. These people surely know how to dig rocks. They were miners after all. On the lengthy journey to Central Australia, about 527 miles north of Adelaide's coastal plains, you'll encounter peculiar sand pyramids dotting the otherwise desolate landscape of salmon-pink dust and tenacious shrubs. Traveling along the highway reveals more of these mysterious formations, piles of pale earth resembling forgotten monuments, often marked by white pipes protruding from the ground. Curious about their purpose? Closer inspection reveals the initial signs of Coober Pedy. While some mounds result from decades of mining, they also signify the locals' expertise in underground living. Those white pipes? Ventilation shafts, a necessity for the subterranean residents to breathe. It might be challenging to envision comfortable underground dwellings, but these are no ordinary shelters. Equipped with all the essentials, from an underground water source to ample electricity, these real apartments offer amenities like television and internet. Stucco-covered sandstone walls prevent dust, while constant mild temperatures and ventilation systems create a livable environment. Drawing inspiration from their unique experience, we can explore the potential of underground living on Mars. But there is more to it. Underground social life is very active. You can find bars, restaurants, swimming pools, and churches where regular religious functions are held. Art galleries, and even hotels. If you ever pass by there, I strongly recommend you have a walk through the carved tunnels of this underground city. It might really be the experience of a lifetime. Pros and cons of underground living. The residents of Coober Pedy, predominantly miners, possess skills that could be invaluable in establishing a human presence on Mars. Mining expertise translates into the ability to excavate and create subterranean structures efficiently. The experience in working with machinery and adapting to challenging environments equips miners with problem-solving skills, crucial for overcoming unforeseen obstacles in extraterrestrial settlement. Moreover, Coober Pedy's dependence on mining for a living provides a parallel to the potential need for resource utilization on Mars. Just as miners extract valuable minerals from the Earth, settlers on Mars might need to extract and process local resources to sustain themselves. The lessons learned from resourceful mining practices could contribute to sustainable living and reduced resilience on Earth for essential supplies. In addition to that, it is important to note that underground spaces can become stagnant without proper ventilation. This was a lesson learned the hard way by residents of Coober Pedy, which is why you'll find ventilation pipes on the surface. These pipes allow fresh air to circulate, ensuring a continuous supply of life-sustaining oxygen and preventing the buildup of carbon dioxide exhaled by inhabitants. Living underground also has its advantages, regardless of the season. Compared to surface conditions, underground spaces offer a more stable and moderated environment. Just ask the citizens of Coober Pedy, who can attest to the fact that temperatures underground remain relatively constant throughout the year. During summer, this means cooler temperatures compared to the scorching heat above the ground. In winter, the Earth acts as a thermal buffer, helping to retain heat and reducing the need for extensive heating systems. However, one of the main challenges of living underground is the lack of natural light. Natural light is crucial for maintaining our circadian rhythms and supporting vitamin D synthesis. Fortunately, there are ways to address this issue. We can take inspiration from those living in Antarctica, where the winter months are characterized by perpetual darkness. In such extreme conditions, scientists and researchers employ various strategies, including light therapy. Light therapy lamps, also known as light boxes, mimic natural sunlight by emitting bright light. These lamps help individuals in Antarctica maintain their circadian rhythms and potentially counteract the impact of reduced sunlight exposure. Hey, before moving on, be sure to like or dislike the video so that we can improve it for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Proposed underground Mars colonies. Living underground on Mars presents significant challenges for humanity. One major challenge would be the significant pressure difference between the interior of a domed human colony, which must be suitable for human habitation at around 1 bar, and the near vacuum pressure of the Martian atmosphere, ranging from 0.004 to 0.011 bar. To address this, a dome for such a structure would need to be securely anchored deep underground. However, there is a simpler solution. A mostly underground spherical hermetic structure with only the dome visible above the ground level. The spherical shape is the strongest geometric shape for containing internal pressure, and the structure can be stabilized by the weight placed inside the sphere. Michel Lamontagne, a Canadian design engineer, has created 2 concept drawings for this type of colony. In his designs, only a domed park is located above ground level, while the rest of the colony is situated below ground. The structure includes a vertical central opening to allow for natural lighting. Another ingenious idea that could be ideal for Mars is the concept of inverted underground skyscrapers. These structures utilize the lava tubes believed to exist on the red planet. These tubes are colossal tunnels that extend deep into the Martian surface from an opening. Similar to skyscrapers on Earth, these structures would be inverted, featuring a substantial central cavity covered by a transparent dome at the surface to allow natural light inside. Surrounding this central void, multiple levels would be designed to house living quarters and public spaces. Nonetheless, a significant challenge associated with lava tubes is the potential scarcity of them on Mars. To address this limitation, the proposal suggests utilizing solar-powered robots to carve out subterranean voids before human arrival on the planet. These robots would leverage the basalt bedrock columns on Mars to craft expensive cathedral-like spaces underground. The excavation process involves progressively extracting larger sections of basalt as the robot diggers move downward from the surface. Importantly, they would preserve robust basalt columns, forming towering dwellings with cathedral-style architecture. In essence, the prudent approach before dispatching humans to Mars involves deploying rovers, robots, and potentially drones for thorough exploration. Ensuring the suitability of the new settlement is paramount when embarking on the journey to a different home. Coober Pedy is not an isolated case. Coober Pedy's underground living is not an isolated phenomenon. Humans have sought refuge beneath the Earth's surface for millennia, showcasing a historical trend of subterranean habitation. This practice dates back to human ancestors who sought shelter in South African caves 2 million years ago, and Neanderthals who utilized French grottos during an ice age 176,000 years ago, creating enigmatic piles of stalagmites. Even chimpanzees have displayed adaptive behavior by seeking refuge in caverns to cope with extreme daytime heat. A notable example is Cappadocia in central Turkey, renowned for its mesmerizing geological features such as sculpted pinnacles and rock spires. The region, sitting on an arid plateau, harbors ancient cave dwellings and underground cities. The discovery of Derinkreu, one such underground city, traces back to a peculiar incident involving disappearing chickens in 1963. As a man investigated the mysterious disappearances, he uncovered a hidden passageway leading to a vast labyrinth of niches, corridors, and the lost city of Derinkreu. Dating back to the 8th century BC, Derinkreu served as a fully equipped underground city with ventilation shafts, wells, stables, churches, and a network of homes. It not only housed a thriving community but also functioned as an emergency shelter for up to 20,000 people in times of invasion. These instances illustrate that Coober Pedy is part of a broader historical narrative where humans, faced with challenging climates or unique circumstances, have turned to the ingenious strategy of living underground, creating remarkable subterranean habitats that stand as testaments to human adaptability over the ages. Do you think we will be able to do the same on Mars? Let us know in the comments below. Hey, our opal adventure ends here. I hope you enjoyed it. If so, please like the video, and we'll see you soon on the channel.